Okay, going quickly here through part of Unit 5, Lesson 2, before we dive in all the way, just reviewing completing the square and quadratic formula. We've already done this in a previous unit, and you've seen them in other classes. And so ways to solve quadratic functions, quadratic equations that we've seen so far is factoring. You saw this in Algebra 1 first. We also did it in Unit 2. Square root property, same thing. You're first introduced to this in Algebra 1. So factoring in the form of ax squared plus bx plus c, breaking that into your binomials and setting those equal to 0. Square root property, where you take the square root of both sides to solve for that. Making sure you do the plus or minus in the front. Quadratic formula. We'll do that below, but Algebra 1, again, is when you're introduced to that. And then completing the square, you were probably introduced to that in Algebra 2. We've already done that, though, so again, just going fairly quickly through this. Remember that when you're completing the square, you're forcing one side of the equation into what's called that perfect square trinomial. So you're getting that pattern where you have a squared plus 2ab plus b squared. So where it will factor as either a plus b quantity squared or a minus b quantity squared. When we're converting, you must end up with like x minus h squared plus k to be able to solve by completing the square. That's our end goal here. We're also going to look at converting standard form into vertex form the same manner. So remember, if you have something like x squared plus 2x, 2/3 x, and you're trying to get that into a perfect square trinomial, then you need to find c. Find your c by taking b divided by 2 and squaring it. And so here we have our b term is 2/3. We're going to divide that by 2, which makes this, which is the same as multiplying 2/3 by 1/2. Those cross cancel and we end up with 1/3. So this is our c term. After we square it, so that becomes then 1/9. All right, so x squared plus 2/3 x plus 1/9 is a perfect square trinomial where we have an a squared term and a b squared term. Notice that those roots are what goes in there. So square root of x squared is just x. Square root of 1/9 is 1/3, and that gives us our b term. This is all plus, 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 so we're following that first line up there. So plus 1/3 quantity squared. Okay, you've already done examples like number 1, so go ahead and try that one on your own. We're solving for x by completing the square. Okay, so go ahead and check your answer here. You're going to move that 3 to the other side and then find your c term and add that to both sides of your equation. That will make the left side factorable as a perfect square trinomial. We can then square root both sides, simplify our radical, and subtract our 5/. All right, so that is your final answer for that problem. Now I wanted to look at number 2 because all of the completing the squares that we've done up to this point do not have this lead coefficient. And we have to take that into account when we're finding, when we're solving our equation and when we're adding things to the other side. So I'm going to start this problem the same way that I did before. I'm going to take 2m squared minus m. I'm going to set that equal to 15, adding that 15 over to the other side. But then I'm going to factor out the lead coefficient. So I'm going to take that 2 out front, and I end up with m squared minus 1/2 m is equal to 15. You could divide that 2 over to the other side at this point in time if you'd like. Okay, so I wanted to look at example 2 with you because it has a lead coefficient which we're not used to seeing and haven't walked through how to approach these problems yet. Completing the square and making this a perfect square trinomial only works if that number is not there. So the first thing we're going to do is get rid of it. And so we're just going to divide everything by 2 and end up with m squared minus 1/2 m minus 15 over 2 equals 0, excuse me. We're going to then start our completing the square process. So I'm going to move my 15 over 2 to the other side. So m squared minus 1/2 m is equal to 15 over 2. Take your b term divided by 2 and square it. Half of half is a fourth, squared is a 16th. I'm going to add that into both sides. And so now I'm going to come up here, m squared minus 1/2 m plus 1 over 16 is equal to 15 over 2 plus 1 over 16. This breaks down into the square root of both a and b. So we have m minus 1/4 quantity squared. This will add together into 121 over 16. You just do that by multiplying this side by 8 to get that common denominator and then add across the top. All right, so we want to get rid of our square, so we're going to take the square root, and that we end up with m minus 1/4 is equal to plus or minus, and remember we're square rooting this and it's both perfect squares, so we get 11 over 4. And then we add the 1/4 over. So m is equal to 1/4 plus or minus 11 over 4. Those already have common denominators. I just need to make sure I do both of them. So I get 1 plus 11 is 12, divided by 4 is 3. And then 1 minus 11 is negative 10 over 4, which is negative 5 over 2. You could plug that in and see if they both work. I'm telling you this one does. Okay, let's run through that process one more time. So when we have this lead coefficient, we're going to divide it out of everything. And so we end up with x squared plus x minus 1/2 is equal to 0. I'm going to add that 1/2 over, so we get x squared plus x is equal to 1/2. Remember to find your c, you take b divided by 2 and you square it, and so in this case it's 1/4. So we're going to add 1/4 to both sides. So x squared plus x plus 1/4 is equal to 1/2 plus 1/4. This now factors as a squared plus b squared, so we get x plus, or excuse me, a plus b, so the square root of those. X plus 1/2 quantity squared is equal to, and keep in mind this is 2/4 if we get a common denominator, 3/4. All right, when you square root this fraction, this is why we did radicals with this. We're going to square root the top and the bottom separately. So we square root, and so coming up here, x plus 1/2 is equal to plus or minus the square root of 3/2. And then we just move this over. So x is equal to -1 plus or minus the square root of 3. And they already have a common denominator, so we just put that all over 2. Or you can keep them separate, -1/2 plus or minus the square root of 3/2. It doesn't matter how you write that. Okay, so that's completing the square. And quite honestly, personally, if it had a lead coefficient like this, I probably wouldn't mess with completing the square. I would use quadratic formula. Remember, quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. They have to be in the form of ax squared plus bx plus c equals 0 in order to solve them this way. All right, so sometimes you have to move things first. So like this, we need to get everything to one side. I always try to make sure my a is positive just because then it's not quite as messy in the bottom of your fraction here. So 4x squared minus 12x plus 9 equals 0. And then go ahead and plug all that in and solve it out. Okay, so we plug this in, and in this particular case, this inside cancels out to 0, and the square root of 0 is 0. So we only have one answer for this one, and that is that x is equal to 3/2. Okay, you can also divide out or multiply through by numbers to make this a little bit easier to plug in. So if I want to get rid of these fractions, I can multiply by that common denominator, going clear back to unit 1, as long as I multiply everything through. So then this becomes 2x squared plus 6x plus 3 equals 0. I can plug all of that into quadratic formula. Watch your signs. And then simplify inside your radical, combine like terms underneath the radical, and then break that down as well. So remember, this is 4 and 3. So -6 plus or minus 2√3 all over 4. All of my outside numbers have a 2 in common, so my last step here is to reduce this. So I get -3 plus or minus the square root of 3/2. And this would be my final answer. And this is x equals that. So x equals -3 plus or minus √3 all over 2. Okay. So looking at those underneath ones, up here we got a 0. Notice we only got one answer. Down here we got a 12. We have 2 answers. If we get a negative underneath, we're going to have that I come out. So you have your imaginary numbers there. And so the number and type of solutions to your equation and how many and whether or not they are real or imaginary without actually solving is determined by the discriminant. And the discriminant is the b squared minus 4ac value underneath the radical. And if it is positive, I have 2 real solutions. If it is 0, you have 1 real solution. And if it's negative, you have 0 real solutions. Instead, you'll bring out that I out of your radical. So let's say you have like the square root of -9, then that would be plus or minus 3i when you simplify your radical. All right, so no real solutions, what we call complex numbers. All right, so we can just look at the discriminant for things. We didn't solve this when I cut it from these notes. So if you have 4/9 w squared minus 4/3 w plus 1 equals 0, I'm going to multiply everything by 9 and clear these fractions out. So 4w squared minus 12w plus 9 equals 0. So all I want to look at right now is b squared minus 4ac. All right, so I have negative 12 squared minus 4 times 4 times 9, which is then 144 minus 144, which is 0. And so because 0, I have one real solution to this problem. All right, which means that in terms of a graph, which we're going into now, this graph will only touch the x-axis one time. That's what this is telling us. So conclusions about finding the discriminant versus solving the equations. Right, the discriminant will tell you how many solutions and what type, but not the actual value of them. All right, so now moving in to the function itself. Remember that the graph of a quadratic is a parabola. And so that's the U-shaped graphs that we get. These graphs have, oh, that was really messy. These graphs have what's called an axis of symmetry, meaning they're symmetrical on both sides of it. They have a low point or a minimum or a maximum, depending on which way it's open, called a vertex. So that center point before it turns is the vertex. I should have drawn this a little bit different. They have a y-intercept. And then they have x-intercepts, and that is what your discriminant tells you. Sometimes they have 1, sometimes they have 2, and sometimes they don't have any. But where it crosses the x-axis would be your x-intercept. We can change back and forth between forms to make it easier to graph, depending on what we're doing with it. From standard to vertex form, we're going to use completing the square process. And standard form is ax squared plus bx plus c, where vertex form is x minus h squared. I should make these equal to y instead of 0, plus k equals y, where h and k are your vertex. To complete the square, just remember that a needs to be 1. Or you can find the vertex, which has a formula, negative b over 2a. Plug that value in for x, and then solve for y, and then just plug it into vertex form. So you can do either of those methods, and I'll demonstrate both real quick here. To convert this from standard form to vertex form by completing the square, everything is done on the right side of the equation. So where before we added things to both sides, here we're going to do it a little bit different. We're going to split up our x's, so x squared minus 7x, using parentheses. You just group them. Then we're going to complete our square like normal. So we take b divided by 2 and we square it. So this gives us 49 over 4. And we're going to add that in here. Okay, so negative 7. Now we have x squared minus 7x plus 49 over 4. Well, because we're adding that in, we need to then subtract it off the back side. So it's as if We have not actually added anything. So we still haven't changed the value of this equation, but we have made it to where we can rewrite this as x minus 7 over 2 quantity squared. All right. And I just did this in my calculator real quick. This is minus 29 over 4. So this is f of x equals, and that's now in vertex form. And I have my vertex there and there. All right. I could also take negative b, so 7 over 2 times a, which is 1, 7 over 2. This is my x value. And I can plug that into my equation. So I can take 7 over 2. Sorry about that. So you plug everything in and solve it out. I'm going to do a little cheating here. I know the y value, because we solved it over here, is going to be negative 29 over 4. Okay, so you should see that you get the same x and same y as you have right here for your vertex form, and then you would just plug those in and be done. So you can convert it either way, but completing the square does work, especially if you have 1 in front of it. So just real quick reminder of characteristics. If A is positive, no matter which format you're in, the graph is open up. If A is negative, it opens down, regardless of whether it's vertex form or standard form. It doesn't matter. Vertex and axis of symmetry. In vertex form, your vertex is just the H and the K. Your axis of symmetry is X equals H. It always goes through the value through the vertex, and so it's a vertical line, so it's X equals the X value. In standard form, you have to do a little bit more math than that. The vertex, the X value, X is negative B over 2A, and then you have to plug in to find Y. Axis of symmetry, again, that negative B over 2A, sorry, it's not a point, is just your X equals negative B over 2A. So whatever you get for that answer is also your axis of symmetry. To find the y-intercept in vertex form versus standard form, plug in 0 for the x and solve. In standard form, it is C. All right. The x-intercept for both formats, you need to plug in 0 for y and solve. So those are going to be your methods at start of notes. So factoring, completing the square, quadratic formula, square root rule. For domain, again, if it is a quadratic, a true quadratic, then your domain is going to be negative infinity to positive infinity, all real numbers for all of them, regardless of format. You have a minimum value or a maximum value. You'll have a minimum value if it's open up. So your A is positive. You'll have a maximum value if it's open down. So again, if your A is negative. Your range is going to depend on whether or not you have a min or a max. So if you have a minimum, your range is going to be from your minimum value to infinity. If you have a maximum, that range is going to flip around because we're going to be open down. So we're going to come up from negative infinity and approach our max y value. And that will be our range. Okay. Same thing with increasing and decreasing. It depends on which direction it's open. If you have a minimum, it's going to decrease into the vertex and then increase out of it. If you have a maximum, it will increase into the vertex and then decrease out of it. Remember that we use x values and parentheses to notate. Okay. So running through a problem, and I'll probably just do this one just to keep the length of this fairly short. But the opening of this is going to be down because A is negative. The vertex, this is standard form. So we're going to actually find axis of symmetry first. X equals negative b over 2a, so it equals the opposite of negative 4, so 4 over 2 times negative 2. So that's negative 1. Then to find our vertex, remember we're going to plug that value in, so we get negative 2 times negative 1 squared minus 4 times negative 1 plus 8. So we get 10 for that. So our vertex is at negative 1, 10. Keep in mind input, output here. C, our domain is all real numbers. Our range, it's open down, so it has a maximum. So our range goes from negative infinity to our maximum y value, which is 10. Right, so we're getting that from there. So all of these we've done without even graphing it. D, my x-intercepts and y-intercepts. Well, my y-intercept is easier to find in standard form. My y-intercept is just 0, 8. We're going to write these as coordinates and not mix them up with like the axis of symmetry equation. My x-intercepts, I'm going to have to solve for those. So I'm just going to kind of do this out to the side here. With the video paused. Okay, so I used completing the square. You can kind of see along the bottom here. So x equals negative 1 plus or minus 5. I do still write that as a point. So I do x-intercept, and then I do negative 1 plus or minus 5, comma 0. You could absolutely split that up and write it as 2 points if you'd like. All right. Part E is your maximum minimum value of the function. We have a max of y equals 10 when x equals negative 1. Because we have a max, we are going to increase from negative infinity to our vertex value of negative 1. Remember, we use x values. And then we'll decrease out of that. So we go from negative 1 to infinity, decreasing. This one doesn't even say to graph it. And so we've done all of that without ever graphing it. But you absolutely could then sketch a graph of it from there using these points. Like I know it's going to cross at like 8. Here, I know the vertex is at negative 1, 10. So this is going to flip on the side. And so it's something that's a very, very rough sketch, and I missed my vertex. Something like that. Okay. And I know I said I'd stop there, but I want to skip down real quick to look at this one just because it's in vertex form. So A, this is again open down because A is equal to negative 2. And I'm just going to pop the answer up for this one. Okay, so again, all of this without graphing, the vertex is at -3, 8. We get that, remember we have to change our sign for the x value. Axis of symmetry then is x equals this value here, so x equals -3. Domain is all real numbers. We once again, it's open down, so we once again have a range that is topping out. We have a maximum value, so -infinity to 8. We get that value from right here. X-intercepts, I just use square root property when I solve these, and this one's a little hard to read. So 0 equals -2, x plus 3 squared plus 8. The first thing we do is subtract the 8 over. Then divide by -2 next to get rid of that off the front. That gives us 4. We can square root both sides. Keep in mind, because we're taking the square root, we're going to have plus or minus 2. So when we do this, we need to do -3 when we subtract that 3 over plus 2, and -3 minus 2, and get our two answers, -1 and -5. You could absolutely FOIL that if you would like to. And use quadratic formula or factoring or something like that. Okay, y-intercept, we plug in 0 for x. So 3 squared is 9, times 2 is -18, plus 8 is -10. And then we have a maximum at 8. It will increase because it's open down from -infinity to that x value at -3, and then decrease out of that from -3 to infinity. Okay, so if you have any questions about that, let me know. I just wanted to show you it looks a little bit different coming from vertex form than it did from standard form. Okay.